Well, thank you for joining us. Warm welcome here. Are you ready for this? Grab a notebook, a pen, pencil, whatever it is that you choose to write with. And let's get ready, because this is math from the void. Math coming at you out of nowhere. Today we have a problem from the 1994 AP Calculus AB exam, question 3. And this is using a pretty light a quartic polynomial function, a fourth degree polynomial, which we have a general idea of what the shape of this is. Yeah, the shape of this can have at max 3 bumps, and since there's a positive coefficient, we know that it's pointing upwards on both sides. Okay, so that's some great insight to use. We suspect that there's some kind of even symmetry, but it's not necessarily true because we have this odd piece in it. So it's neither even nor odd. If there were only even terms, powered terms, then this would be a perfectly even function and symmetric across the y-axis on the left and right side. But we just know that it has some bumps. It has potentially 3 bumpies. Okay. Now we're going to write an equation of tangent line. As soon as you see this phrase, you should stop everything you're doing and immediately write this down, because this will likely give you 1 point just for writing this, dude. Isn't that amazing? You can get a point just for writing this equation down. And it also tells you what it is that you need to fill this equation. So we need 3 things. We need the x value, the y value, and the slope. You can think of it as 2 things, I guess, the point and the slope. That's why we write this in point-slope form. And they've graciously given us the point, tangent to the graph at the point. So this is our x value, and negative 28 is our y value. So all we have to do now is figure out what is the slope. This is very easy to do. We can just take the derivative. F prime is going to give us 12x cubed plus 3x squared minus 42x. And then we can plug in 2. So this is going to give us 12 times 2 cubed, which is 8. 8 times 12 is 96, plus 3 times 2 squared, which is 4. 4 times 3 is 12, minus 42 times 2, which is 84. So if we take the big guy and this negative guy, combine them, that's 12 with another 12, that's 24. So a slope of 24, that is our m value. And now let's just put it all together. This is going to be y plus 28. Be very careful with that. Y minus the y value. You can easily not get your point because you put y minus 28, whereas the formula says y minus the y value. That's y minus negative 28, which is positive 28, equals the slope 24 times the quantity x minus 2. And you can leave it in that form. You don't need to put it into slope-intercept form. If you really wanted to, I mean, you can, but there's just no reason to do that. It's a little bit of extra work, and if you were to make a mistake, you would lose your point, man. So you don't want to lose your point, right? Yeah, so just some advice that you don't need to write it in this format. Okay, part B, find the absolute minimum value. And this is consistent with the fact that we looked at this graph here, sketch of this graph, and we know that there's going to be some lowest point. We don't know exactly where it's at, but there's going to be some lowest point. And it says, show the analysis that leads to your conclusion. In other words, how do we know that it is the absolute minimum value? Well, let's find the derivative and when it equals to 0 so we can find these flat points. So we take the derivative again over here, or we just use the derivative again, I guess I should say. We have 12x cubed plus 3x squared minus 42x. So we want to find when this is equal to 0 or undefined. It's never undefined because it's polynomial. Let's factor out 3x, and that will leave us with 4x squared plus x minus 14 equals to 0. And you can solve this in many ways. We can factor this down in many different ways. This is going to be something like 4x. Well, let's do it the old school way, shall we? Make our little diamond here. Negative 56 and a plus 1. That's going to be 8 and negative 7. So let's try to factor this by grouping. Plus 8x minus 7x minus 14. That's going to give us 4x with x plus 2 and that's going to give us negative 7 with x plus 2. Therefore, our factorization of the derivative is 3x, 4x minus 7, x plus 2 equals 0. Okay, that gives us some critical points. X equals 0, x equals 7/4, and x equals negative 2. Now we can put these on a chart, and we can see which one is associated with the low minimum values. So here is the chart. We have 0, we have negative 2, and we have 7/4. 7/4 would be the most irritating number to plug in to the original function, so I kind of suspect that that's where the absolute minimum is going to be, but we'll just have to see. Let's put this on a chart, good old chart. And the overall product of these factors is the overall derivative, f prime. So that makes that 0, that makes that 0, that makes that 0. Let's follow the pattern here. Plus on the right side of the zeros and negative on the left side of the zeros. If you haven't watched my video on the chart, go ahead and do that. I'll post the link somewhere in this video so you can see it if you haven't already watched it. You should be very familiar with the chart. It's going to help you out so much when you do calculus. And so let's just multiply these signs. We have a negative, then a positive, then a negative, then a positive. So we have a minimum value here at negative 2, and we have a minimum value. So this is a relative min at x equals negative 2, but we don't know what the y value is. And then we have a relative minimum at 7/4. Either one of these is possibly the absolute minimum, relative minimum at x equals 7/4. So these are our only candidates for which one could be the absolute minimum. So let's go ahead and plug those in to the original function, that is. So f of negative 2, that's going to be different from what we did in the first part, where we plugged in positive 2. So this is going to be 3x to the 4th, negative 2 to the 4th. Let's see, plus x cubed, so plus negative 2 cubed. And then minus 21 times negative 2 squared. Okay, let's see what that comes out to be. So we have 3 times 16, which is 48, that's positive, minus 8, and then minus 21 times 4, which is 84. Okay, so if we have 40 minus 84, that's negative 44. That's quite low indeed. But we have to check 7/4, which, like I said, is going to be the more frustrating one to check. 3 times 7/4 to the 4th power. Yeah, you weren't going to get away with this one without working with some fractions. 7/4 cubed minus 21 times 7/4 squared. Now, one thing that I'll mention is 7/4 is not quite 2. It's smaller than 2. So when we square it, it's going to be smaller than 4, right? So when we finally do square that, all right, when we square this, also when we do it to the 4th power, geez, this will be a pretty big number. Let's see, 49 squared is 2,401, and then times 3 is going to be 7,203 over 256, beautiful number, plus 343 over 64 minus, let's see, that's 49 times 21, which is 1029 over 16. So the best thing to do here is notice that these denominators are close to each other. All we need to do is multiply the top and bottom by something. So we multiply the top and bottom by 16. We multiply the top and bottom by 4. And already I get the sense that this is going to be a positive value, but we'll just have to see. So now that we have everything with the same denominator, 7203 plus 4 times 344, that's 1372. The beauty is that even if I'm off by like 1 or 2 or 3 small values over 256, it shouldn't massively affect this. But, you know, write this stuff out carefully. Make sure that you're doing your work carefully. You don't have to try to do it all in your head like I am. In fact, I'll be very careful about this. Let's do 49 times 21. That was 7/4 squared is 49 over 16. So we're going to multiply that times 21. Let's see, this is 4 plus 18 is 22. 2 is going to be 10. Yep, 1029. And then we're going to multiply this by 16. So let's see, we get a 4. Let's carry a 5. So we have 14 plus 12 is 26. Carry the 2. That's going to be 4. That's going to be 6. That's going to be 1. And yeah, I think that's about it. So minus 16,464. This is all over 256. And this takes you back to 3rd grade, doesn't it? Like just adding and subtracting some basic numbers. So let's see, we're going to have 16,464. That's a negative technically. And then we're going to add these together. That's going to give me 8,575. Oops, let me line them up properly. 8,575. And if we subtract these, the result needs to be negative. But if we subtract these, let's see, we're going to get 9. That borrowed, so we're going to get 8. That borrowed, so we're going to get 8. That borrowed, so we're going to get 7. So 70, negative 7,889. I was wrong about thinking this is a positive. And now let's see if this is more than 44. So I'm going to do something kind of silly here. I'm going to call this negative 7888 over 256. It's technically a little different, but the reason why I want to do that is because I can divide these by 2 really quickly. So this is going to be negative 3944 over 128. And then I can divide this by 2 really quickly. This is going to be negative 1972 over 64. And then I can divide this by 2 again. This is going to be negative 986 over 32. I can divide this by 2 again. This is negative 493 over 16. And now I can pretty much tell that this is not going to be very large. Let's just, for the heck of it, convert this again slightly to negative 492. That way it divides by 2 nicely. And we're going to get negative 246 over 8. Divide this by 2 and we get negative 123 over 4. And so this is finally like pretty easy to divide. This is approximately negative 30.75. So even though I rounded stuff just a tiny bit, it's not going to massively change that from the negative 44. So we did all that work, and a little frustrating that the true absolute minimum was negative 44. So we can say abs minimum. And if they want to see the analysis that led to my answer, fucking look at all that shit, right? Excuse my language, but like that's plenty of showing. So the only possible lowest points would be where the minimums happen. That's where like the low points happen. So we say absolute minimum, of negative 44, and it occurs at x equals negative 2. All right, so that answers part B quite thoroughly. Now, part C is actually pretty nice. It says find the x-coordinate of each point of inflection. Remember that a point of inflection happens when f double prime changes sign. It's not enough that it equals to 0 at some point. It has to change sign. So let's just analyze the second derivative, shall we? We have the first derivative already. So the second derivative is going to be, I think, 36x squared. What else do we got there? Plus 6x, is it? Yeah, plus 6x minus 42. Is that about right? Yeah, looks about right. So when does this change sign? Well, of course, we can just divide everything out by 0. By 6, sorry, by 0. Divide everything by 6. And this is a quadratic, which we know is going to change sign at some point, right? We're going to have 2 points of inflection because a quadratic crosses the 0 and changes sign twice. But let's just factor this bad boy. 6x, I think it'll be plus 7 and x minus 1. Does that work out? Let's see. This is 6x. This is 7. So, negative 6x, and this is 7. So that makes 1x. And then, of course, these make 6x squared, and, of course, these make negative 7. So we can just put this on a simple chart. We're going to have negative 7 over 6. We don't have to plug negative 7 over 6 in, don't worry. And we have our factors of the second derivative here. 6x plus 7, x minus 1. Therefore, the overall is f prime. And there's a 0. There's a 0. Follow the pattern. Negative on the left, positive on the right of the zeros. And then we multiply these signs, and that's going to give us some behavior here. So we can confirm that these check out. This is going to be a point of inflection. This is going to be a point of inflection. Now, the question did say only the x coordinates, which is nice. We don't have to plug these in to find the y values. Don't waste your time and plug in the x's to get your y values. So we can say, we can just say at x equals negative 7 over 6 and 1, f double prime changes sign. So f, remember, f has a point of inflection. We don't say that f prime or f double prime has a point of inflection. We say f has points of inflection. At x equals negative 7 over 6 and x equals 1. Now, did I have to write that all over again like that? Maybe not, but if it takes you 5 extra seconds to write it and you guarantee that you're going to get the points, do it. There we go. That was a pretty fun problem. It involves some computational stuff. So some of the things that I skipped by through quickly, this would have been expected in 1994, that you know how to like multiply some fractions and stuff. It's really not that crazy. I know students nowadays are honestly very spoiled with the fact that they can use calculators that are just in their pockets at all times. That's not going to be the case when you're on a no calculator section. So you need to be prepared to do some of this basic arithmetic. Literally, this is like, I think I said like 3rd grade or whatever. I don't know when you learned this, but like 2nd or 3rd grade, you should be pretty competent with like multiplying numbers. Okay? So that'll do it for me today in the void. I will see you next time. Keep studying, keep practicing. Make sure that you're pausing the video before I walk you through this so that you can try it on your own. And make sure that you're fitting yourself in roughly around the 15-minute mark. Now, some of these questions are easier. You should do it in about 9 or 10 minutes. That'll give you more time on the exam for the harder questions. That's enough for me today. I'll see you guys next time. Thanks for joining.